This project is our prestigious project, has been constituted in light of our Honorable Chief Minister's flagship program, that is Jan Jeevan Haryani Mission. And cost of this project is 4,174.81 crore, and just now its progress is likely up to 90%. Next. Next page. 151 kilometer from Hathida to Gaya town. And in this project, we are feeding drinking water to namely 3 towns of Bihar, which is water scarcity and scare town, that is Rajgir, Nawada and Gaya. In this project, we are lifting flood water in monsoon season in 4 months from July to October, and we are lifting around 80 meters from Ganga up to Gaya, and we are creating 2 huge reservoirs. One is at Gaya and another is at Rajgir, and there we are storing water, raw water for 8 remaining months, and we will supply throughout whole year drinking water after purification to around 9 lakh people in Rajgir, Gaya and Nawada. Next. Just I told it is written, this project has been considered in light of our Chief Minister's flagship program, Jal Jeevan Haryani Mission. It is due, this project is formulated due to groundwater table is lowering day by day in this area, and there is a scarcity of drinking water. And in this project, we are utilization of flood water, which was unutilized during monsoon, and it is going to in Bay of Bengal. So we are extracting those water in monsoon period, and we store them in reservoir for 8 months, and then we supply after purification. Next. In this, water demand has been calculated up to 2051, and by a stage wise we will increase the our supply according to the demand. Now we are constructing this project for demand up to 2021. And gradually we will increase our capacity and according to the demand. Next. Objective of this project is, as I said, utilization of excess water from Ganga for 4 months during monsoon period, July to October, and we will store that also water for 8 months in 3 reservoirs, Rajgir, Gaya and Nawada, and we'll supply water by treating raw water in water treatment plant. 3 water treatment plant has been constructed at Rajgir, Nawada and Gaya towns, and laying of pipelines along existing road has been done. Next. Benefit of this project is we will create employment for people in this area, socio-economic benefit with enormous convenience of drinking water to urban and rural people and animals, and by storage of water in forest region of Rajgir Reservoir in Nalanda and 83rd Reservoir in Gaya, groundwater recharge will be done, facilitated, and ultimately benefit flora and fauna, including ecosystem. As such, the project is techno-economical viable. Agriculture produce will increase due to improvement in groundwater level. Also, wildlife sanctuary at Rajgir will be provided water from proposed reservoir for various animals in the area and also water bodies inside the sanctuary. Religious places such as Brahmkund, Saptadhara, etc. in Rajgir, that is hot spring, has become devoid of water as fallout of alarming groundwater depletion. Declining rainfall and inadequate recharge of groundwater, overutilization due to increased population appear to be main reason for decline in discharge in Rajgir hot spring. Next. Project scope are the following: conducting preliminary investigation and preparation design. Actually, this project has been given to agency as a trunky basis, and these scope have been formulated to meet the this project, and approach channel, intake well, house at Hathida at Mokama, where we will extract the water from Ganga, and laying MS pressure main pipe from Hathida Mokama to Gaya, that is 150.58 kilometers. There is detention tank at Motnaje, Nevada, with pump house, delivery system, storage reservoir at Rajgir, Tetar, and along with associated pumping station. Water treatment plant for Rajgir at Mutnaje, that is 24 million liter per day, and for Nevada, that is 36 million per day, and for Gaya and both Gaya at Manpur, that is 186.5 million per day. Design, supply, commissioning of electromechanical equipment such as vertical turbine, pumps, HSC pumps, SCADA system, etc. Design, supply, erection and commissioning of 132/33/33/11 kVA substations, operation and maintenance of electromechanical, hydromechanical works for 5 years, connection of water distribution system from WTP, Rajgir, Nevada, Gaya and both Gaya town. In this project, we are giving maintenance for 5 years to the agency that is incorporated in that project cost. And we are also laying distribution system in various towns such as Rajgir, Nevada, Gaya and both Gaya towns. Next. These are the few pictures, that is intake well at Hathida Mokama, where we are extracting flood water from Ganga. Next. And this is the few pictures for laying MS pipe from Hathida to Rajgir, in between Rajgir. Next. And this is detention tank at Motnaje, Nevada. This schematic diagram from detention tank. We are taking water to reservoir from here, and one pipeline is for Nevada town and another is for Rajgir. Next. This is highest level Tetar reservoir, which is situated in this pipeline at highest altitude. We are
so sorry to interrupt you. I request you please conclude now.
Okay. Next. This is Tetar reservoir. Next. And this is a water treatment plant at Nevada. Next. And this is a water treatment plant at Gaya. And this is a Rajgir water supply schematic. Next. This is few pictures of different components. Next. And this is Gaya water supply line diagram. Next. And this is Gaya WTP progress of work. Next. And this is the Nevada town water supply. Next. Next. Supply of Ganga Jal intake well to descent tank operable. Operation of the storage of Ganga Jal water in Rajgir reservoir is under progress. Operation of Rajgir water treatment plant is also ready, and distribution of purified water to Rajgir town is under trial run. Next. Thank you.
Jury members.
Alok sir, very good
Sir.
project. But normally in such a large project, there is always a time and cost overrun. So
Ji.
when this project was originally scheduled to complete, and what is the full completion date now expected now?
Sir, this project is started 2 years back in Corona period, but overcoming the challenges of Corona, this completion period is March 2023. But we are ahead of the completion period, and we are likely to complete it by December. But our project completion period is 2023.
Okay. So means there is no time and cost overrun.
No, sir.
Okay. Very good, sir. Excellent work. In fact, this will augment the water supply in your area.
Yeah,
But
yes.
can you also think it connecting or supplying water to other areas besides these three major cities?
Yes, sir. We have earlier formulated for few more towns, but due to some constraint, because this type of project in Bihar, we are constructing first time. So we
Sure.
have limited to these three towns only. And previously distribution system we are not taken up in this project. But after our Honorable Chief Minister guided us, and we are taking distribution system also in these towns, so that we have delayed for other expansion just for now this we will complete, and then again we will formulate another project after experience of this. And because in this project you may face lot of challenges in maintenance, because in maintenance, if it drop down, the water supply is stop, then enormous situation will occur. So we will 1 year we will first see how maintenance will be done, then we will try to expand it.
Thank you, sir. Excellent work.
Thank you, sir.
Sir, is there any flood moderation component in this project?
No, sir. Just we are taking flood water and utilizing it. There is no constraint to taking water. That was unutilized water which was going into Bay of Bengal. So the first time this idea has been formulated to use unutilized. We will fetch Ganga water only in 4 months. And in that 4 months, in July to October, we will take out the water from Ganga and we will treat it and supply to the towns, as well as we will store for 8 months in different reservoirs.
Okay, it's a good concept. Thank
Yes.
you.
And the Kaveri is the only source and lifeline of Tamil Nadu, which runs about 800 kilometers, in which 416 kilometers flows in Tamil Nadu. Mettur Dam is the first reservoir in the Kaveri, and this project location is at about 106 kilometers from Mettur. The necessity of the project. Mohanur Channel at present is offtaking directly from river situated in the Namakkal district, and it's of length of 19.56 kilometers. Due to the progressive lowering of the river bed right from the Jedabalem bed regulator, the farmers were not in a position to get the irrigable water for their agricultural crops. Due to that, the farmers made a temporary arrangement known as Korabu works, which actually runs parallel to the flank or the bed near the bed of the river, so that according to the gravity, till they attain the gravity level of the flow, they will start the regulation from that point. The existing Mohanur channel is located 6.75 kilometer downstream of the ongoing project of Nandepulur barrage. From this point, the farmers take up the Korabu works till the existing point, and that Korabu work is only a temporary one, and when flood comes, they get inundated, and the farmers could not get a continuous supply of water for their irrigation. This is one of the necessity of the project. And in the right side of the river Kaveri, where the Ganga channel is located, the access of the barrage, the Ganga channel is located just upstream 200 meters of the access of the barrage. Even though the Ganga channel is on the river bed itself, due to the lowering of the river bed, the Ganga channel was irrigation supply was not done right from 2014 till date. We have adequate records that Ganga channel had nil supply for the past years, and this Namakkal region and the Karur district area and the taluks, namely Parvativelum taluk and Pugalur taluk, is an overexploited region as far as the groundwater infiltration is concerned. And the fourth one is Tamil Nadu Paper Mills Limited, one of India's leading paper mill company, used to draw 14 to 16 mgd of surface water from Kaveri. During the severe drought in 2014, there was no water in the river, and there was acute shortage, and around 46,000 metric tons of paper and 22,500 metric tons of paper board was not able to be produced, and there was a huge revenue loss of 160 crores to the company. This forms the necessity of constructing a barrage across river Kaveri in this location. The benefits of the project. To overcome all these problems, the benefits of the Mohanur Canal is, at present, the Mohanur Canal is offtaking directly in the left side of Namakkal district, and you can see that the Mohanur Ketchluises is being constructed right at the junction point of the left bank where the barrage is located, so that the farmers can get the assured supply of water throughout, and the acreage benefited out of that is 2,583 acres of Ayakat. And in the same manner, Ganga channel in Karur district will definitely be irrigated with assured supply of 1,458 acres in Karur district will be benefited out of this project. And drinking water scheme pumping wells, which are located in the upstream of the barrage, where 0.8 TMC of water is stored. there are 6 number of pumping well schemes in Kannur district and 9 numbers in the Namakkal districts will be benefited out of this, and the total number of population which will be benefited with this project is in Kannur district it is 34,993 population will be benefited, and in Namakkal district 71,612 persons will be benefited. Benefits for the industrial purposes. As said earlier, the backwater profile length of constructing a barrage to a height of 5 meters will be around 8 kilometers. The TNPL, that is Tamil Nadu Paper Mills Limited, which is located about 3.5 kilometers in the upstream of the barrage. Infiltration wills in that get complete assured supply so that their water supply will not be devoid. They will not be devoid of the water supply. And in the event of drought and even in the lean water season also, there will be a minimum head of 3 meters, which will result in no revenue losses will be got by that company. The challenges of the project. Routing. The construction of the barrage is actually to be founded in the rocky area. The barrage portion has to be founded in the rocky area. The grouting techniques, we are following it to safeguard the structure against the rate of seepage and to reduce the deformity of the shattered rock. Grouting is adopted. This grouting is adopted by calling upon the Geological Survey of India people, and their team come and visit those areas, my barrage site location, and they give the pattern of that, and according to the pattern we start work the other components. And another one challenge is that U-drain arrangement. In order to release the uplift pressure expected to be exerted at the base of the spilling basin, a drainage arrangement with required pipes below and above foundation is provided. Water collecting system consisting of half round tube pipes and concrete is being filled in that, and at the upstream we have a non-return valve so that the water pressure gets released in the non-return valve area. The challenges of the project. Kaveri is a continuous flowing river all the 365 days, even with a lean flow of at least 2,000 cubic for drinking water purposes. In this river bed, an open foundation of around 42 meters floor length for a length of 1,056 meters makes a big issue because of the challenge of dewatering problems. The dewatering problems is sorted out by various means such as open dewatering method we follow. Then if the layer in the sand, it is better that we have temporary well point dewatering method. In some places, after getting there are various layers. In the first layer will be sand, the other layer will be soft disintegrated rock, and the next layer would be the hard rock area. In certain cases, after we encounter a sandy layer, we may sometimes get a layer of pebbles also. During that time, when well point method or vacuum dewatering pressure method could not be done, and during that time we go in for multi-stage dewatering, and this is a huge process for an open foundation earthwork. This is the challenge faced in the project. And coming to the uniqueness of the project, since this project is located in a flat terrain, the slope of the river bed is 1 in 1,700. Considering the aspects of the location of the barrage, the only available thing we can construct in this riverbed is just a barrage to store the water and to make irrigable to the other areas. This is one of the uniqueness of the barrage. This is the lesson learned that in flat terrains, only a barrage structure could be constructed and water can be stored and utilized for other multi-level purposes. And another uniqueness of the project is the SCADA arrangement. After the regulating structure of Metur, this is going to be the first structure with the supervisory control and data acquisition, which is yet to be adopted. This stays much ahead of the conventional method of delivering water. By monitoring the water flow, the shortages and the uncertainties of the water to the daily users shall be monitored effectively. And encompassing of all these things, agriculture is benefited around 4,041 acres of land is getting irrigable, and over exploitation zone in the groundwater is recharged, and for drinking water purposes 1,06,605 people are getting benefited from Karur and Namakkal districts, and as an industrial usage 160 crores per year for the Tamil Nadu Paper Mills Limited will be given water. That's all. Thank you very much. This is the importance of my barrage work, and it comprises as a wholesome work. As we have studied in our earlier days, water is used for agriculture, domestic, industrial, and drinking. My project encompasses of all these things, and that is the uniqueness of the project. And the constructing a barrage across the river Kaveri in a flat terrain is the lesson learned from this barrage. Thank you, one and all. Thank you, jury members.
Thank you, ma'am. This is a very multi-purpose project. You have given so much benefits to the entire region. Excellent work. Thank you very much.
Thank you very much, sir.
Thanks, ma'am. Good project. No specific question to ask.
Native reservoir is constructed across the river Kaveri in Salem district of Tamil Nadu. To fulfill the need of agriculture and to divert the excess floodwater from Native reservoir, the scheme is proposed to construct a main pumping station on the left flank of reservoir located in the Tippamatti village of Mettur Taluk. Mettur reservoir at the Tippamatti station. Need and necessity of the scheme. Sarabanga basin is one of the Kaveri sub-basin and is away from 7 kilometers from Mettur town, or in over-exploited zones. Since most of the time, most of the tanks are dry in nature. Hence, the groundwater table in forwards goes down to a depth of 300 meters and more. The Sarabanga basin is at an altitude higher level comparatively the Mettur reservoir. Hence, the pumping is needed for lifting water to filling the tanks. Even though Mettur tank surplus in the tanks, namely Mettur and Ganga, Gadapadi, Sarabanga Taluk do not fill to its original capacity. In that area, the farmer are cultivated only the dry crop instead of wet crop. There is scarcity of drinking water in Sarabanga basin. In this project, we have decided to lift the excess flood water from the Mettur reservoir. That means 5 MCFD. that is called 0.5 TMC. The original capacity of the metal soil is 93 capacity. We can draw water only 0.5 TMC. To improve the surface and the groundwater potential in the overexploited area in Sarbanga basin of 7 districts. The total total area of 4,062 acres has been stabilized, and the additional food production will be improved 8,441 tons. Our objective is improving Sarbanga basin tanks in Chala district. It is nearly 25% of Cape to be stabilized, and to sustain agricultural operation and to avoid the migrants of the agriculture. The flow diagram showing the details of the scheme. There are 79 tanks are going to be benefited. The green line represents the piping line, and the black line represents the leaking canal. By using the pipeline and the leaking canal, water supplied to the fields. In this scheme, there are 3 pumping stations have been constructed for lifting water at various levels. The main pumping station is constructed at Polo village of Metro to lifting water height of 139 meters, and another sub-pumping station are constructed at Valanapuram and Kadandari. About 60 and 40 height, 40 meter height, 40 kilometer height, 40 meter height, respectively. The land acquisition work has been completed for about 74.58 hectares out of 109 hectares. Where land acquisition is in progress. By implementing this scheme, the Sarbanga basin would be sustainable and improving the welfare of the farmers. We are achieving the project credits by the way of improving irrigation facilities, increasing food production, more employment opportunities, and thereby improving socio-economic status of the people. Groundwater recharge can achieve 4 lakhs. Here we are showing the challenges and the remedies. During the flood season, we are getting excess flood water with a minimum period. That time we have to utilize the flood excess water to the maximum extent. By the way of introducing cutting edge technology, it is the new technique, sir. By introducing cutting edge technology to design the pumps and pipes. Another one. Sarbanga subbasin is not a flat terrain, is not a flat terrain, and it has more number of ridges. For that, we have to fix the alignment of the canal in recharge zone to improve subsoil water table in the command area. For that, by using soil zonation map and the contour map with the help of experts from technical institutions. It was very difficult to connect the tanks and the higher elevated with the existing leaking canal. For that, introducing sub-pumping station to lift water to higher altitude tanks. Uniqueness of the scheme. The supply of pumping water for a height of at various levels, like 139 meter and 60 meter and 40 meter, without any intermediate sub-pumping station. further flow through open canal to feed to lower down tanks and ponds. The uniform model to transfer the excess flood water by the way of pumping and gravity network at higher level. Assured irrigation can be established for the existing dry tanks and ponds. Outcome of the scheme. This project is the project becomes a model for transfer of surplus water to existing dry tanks for better availability of stabilization items. The uniform model of to transfer excess flood water between the subbasin by combination of pumping and gravity method. The groundwater table increases for about 30 centimeters in the over exploited area. Thank you, sir.
Very good project, sir. In fact, for how many months do you have a surplus water because of rain?
We have completed 2 years, sir. We are going to complete the project November coming November. Surplus will be getting only 30 days. Only. We are getting only 30 days.
Only 30 days.
30 days.
Oh, I see. And for this Matur Dam, I think this is a power project also. There is a connected hydropower station also.
Yes, sir. Yes, sir.
And that hydropower station cannot be run to generate additional power because of rainwater.
Not done, sir. Not done.
Okay. You have mentioned that the groundwater level is more than 300 meters and beyond also. So can we think of utilizing this 30 days rainwater, excess rainwater for groundwater recharging also?
Not possible, sir. By this project, we can improve the groundwater capacity.
Okay. Thank you, sir.
Thank you.
Thank you, sir.
So the only impact I see in your project is that are you there, sir?
Yes, sir.
The only impact I see is that you are going to increase ground level water to the extent of 30 centimeters. Is it? In your presentation, you mentioned that the groundwater will be increased by 30 centimeters because of this.
Yes, sir. Present only 30, sir. Present only 30, sir. We are observed the data, sir.
Okay. So only the rainwater is available for 30 days and the rest of the time this project will not be used?
Not rainwater, sir. This supply of lifting flood water, sir. Excess water from Karnataka. Excess flood water from Karnataka.
Okay. Thank you.
Thank you.
Engineer. Myself, Shivalingam, superintending engineer associated with the engineering project. So this is first interlinking project in Tamil Nadu. We have started in the year 2008 and 9. This is basically linking the Tamrabarani, Karumeniar and Nambiar River of the southern part of the Tamil Nadu state. Actually, we are taking flood water from Tamrabarani and linking the southern rivers of Karumeniar and Nambiar of the Roham area. So as we know that Tamil Nadu is one of the most water stressed state in India, and perhaps 1/3 of the topographic area of Tamil Nadu is prone to acute stress. So the groundwater level has gone down more than 300 meters or 400 meters in many of the areas. And also the irrigation industry is also getting affected. And only food security and water security is a question mark there. So for that, our Tamil Nadu government has formulated one interlinking project within the state of Tamil Nadu. Actually, Tamarapani is the only perennial river originated and ends in Tamil Nadu. So we have some surplus waters from Tamarapani. So we put across one structure, diversion structure across Tamarapani and diverting water to the tune of 3,200 cusecs, hardly for 10 to 15 days in a year. That's all. So without affecting the irrigation interest of the existing Tamarapani basin, so we are diverting the surplus water to 3 river systems. So linking one and after one and after one. So about 25,000 hectares of irrigated land is being stabilized besides bringing water to livestock and other area. So actually, this is basically to stabilize the irrigation in 23,000 hectares and also adding some new high tech to the tune of some thousand hectares as well. So basically, we are filling 252 tanks and ponds located in this area through groundwater recharge. About 50 villages and 50,000 farmers are getting benefited. So it's basically a bacteria canal. The length of the canal is about 75 kilometers total length. So we have created some infrastructures as well, some diversion weirs, as well as some two reservoirs, everything else, some CD boats, everything. And we have a crossing of railway bridges in Tirunelveli to Kanyakumari railway bridge we crossed. And there is one NH44 which is national to Kanyakumari. So we have crossed some entire bridges as well. And we have created a lot of cross development CD boats for this air project. Actually, dependability is estimated as 73%, and out of the surplus of 18.7 TMC per annum, so we are replacing just 2.76 TMC per annum. So that is the effects of this project. So rightly said, we have a multi-purpose project. Actually, through groundwater recharge, we are stabilizing the existing market, number one. So number two, we are increasing some new items also, new development. And actually, there is one bird sanctuary, the bird sanctuary. It is one of the most famous sanctuary in South Asia, where more than 300 varieties of birds are coming in the season. Even migratory birds from Siberia, Russia, and even European countries come over there. So due to acute shortage of water and drought, so this sanctuary is getting disturbed. So we are doing water, ensuring water to the sanctuary as well. Actually, there are many agro industries based on in India. Another is some Purangulam, that project is also there. So we are giving water supply to those coastal villages as well. And the Satangulam, the same way are the coastal villages located near the coast, where groundwater is being depleted or overexpanded, for which seawater intrusion is there. That's a real problem there. So we want to check those coastal intrusion of seawater into the land area. So that is one point. So this is a schematic diagram. So the thing is, we are diverting surplus water from Tamarapani and we are getting Pachia, Karolina, and Ganga. So this is the area. And we have a number of challenges during construction. Actually, this project was commissioned in the year 2009. So land acquisition is a major problem here. Actually, we need 1,227 hectares of land to be cleared for making this canal and other hydraulic structures, out of which 1,000 hectares of land is from private landowners. So LA is a very complicated and very hectic issue. So we are keep on moving land acquisition to our district administration, and many of the private landowners come to court and all those things. So a number of litigations were there. So we sort out one by one, and finally we got the lands. So right now the project is completed in stage 1, stage 2, stage 3, and stage 4. So 1 to 3 has already been completed, and in stage 4, almost 50% of the work has been completed, remaining works are in progress. So hopefully this project will be completed within this March 2023. So we started this project with initial cost of 369 crores, and due to cost in escalation cost and escalation land acquisition cost of land and some of the additional quantities, additional items and some new components. So the final investment comes around 933 crores as of today. And actually, we have 5 million cubic meter of soil has been excavated for the open canal. So this is the open canal with carrying capacity of 3,200 cubics, running about 75 kilometers. So how to dispose all this excavated hard rock and soft rock and even gravel is a very big challenge for us, for which we have initiated some disposal method along with district administration. And in the tail end, there is one rare earth called some plutonium mixed earth, and Indian Rare Earth Limited has come forward to consume those rare earth. It is called terry sand. So terry sand is nothing but similar to desert area, so almost sandy bed. So we are running a canal through the terry sand for about 6 kilometers, and we created some reservoirs as well, small reservoirs as well. So that is there. So actually we are dumping all those excavated materials in both government and private lands. So that is the very big thing. But anyway, we have found some alternate arrangements. Another thing is challenges means crossing NH, the Nahai highway and the railway track. So those railway tracks are fully functional, and so it is very difficult to handle those excavation across the railway track. So 50% we are doing, and again 50% the stage 2. Actually, that all the works are carried out by railway department, for which we are paying the cost for the construction, reconstruction, restoration hours. Similarly for the Nahai. So Nahai also we have amount, capacity the amount to those guys. So they are taking care of the construction costs. Okay. So those things are progressing right now. And apart from that, as in any other public infrastructure projects, there are a number of challenges over here as well. So mainly technical and some administrative challenges as well as social challenges as well. So the thing is, so why this project take long time for a decade means mainly due to land acquisition. So more than 1,000 hectares of land acquisition in private lands. So some people may come forward and submit to resistance and go for court. So all kind of hurdles were there, and of course the 2 district administrations, Tirunelveli had come forward and constituted special cells for acquisition. And so right now almost 100% acquisition is over, except 1 or 2 litigations are there. But anyway, by all kind of interventions, so we came to a closing point. So probably within 6 months we will be able to complete the entire project, and probably the floodwaters of 2023 from Tamarapalli will be lifted through this canal and put into benefit of all these groundwater areas. So this is the first project, as I already said. And second one, we already started the Kaveri River parking. This is another interlinked project in Ganga. So this is the thing. So this is the open canal. It is all unlined channel. Carrying capacity is 3,200 cubics. So this is the tail end of the project, where this is terry sand. We call it almost like a desert, something like Rajasthan. So here we challenge is how to stabilize the slope of the canal. So that is one. So we are looking at it, and IIT Madras and other institutions, our knowledge partners are working on that part. So we are making some proposals for stabilizing the terry sand canals for 6 kilometers. So that is going on there. So this is the canal of precarious canals, terry sand in the southern part of the world. It is a specific area, not everywhere. Probably 6 to 7 kilometers we met with the sand of the sand also. And many external agencies are working on it. So how to go about? So that is the thing. And this is the some structures, few structures are created for this interlinking projects. Thank you so much for giving this opportunity. So any questions I can answer. Thank you so much.
Very good project, sir. When you are, how do you take care of this sandy soil? What treatment is done for this irrigation project?
Well, sir, actually it is really a tough time for us to excavate canals and to protect the canals, like you said. Actually, studies are going on, and we invited some private consultants from Germany as well. Actually, we made it 2:1 slope right now, and still it is unstable, so totally unstable. So we need to allow percolation to the canal. That is number one. So without affecting the percolation, how to protect the canal is a challenging one. So we are working on it. Actually, we proposed one pilot project for at least 1 kilometer to start with, and based on the success story, we want to upscale it for the entire length of 6 kilometers. So it is a really challenging problem. We are looking at it.
Sure. Thank you, sir.
Thank you so much, sir.
So this is the third project we are saying from Tamil Nadu on the same subject, that rainwater is to be somewhere need to be utilized so that this dry area you can use it for drinking water or for agriculture purpose. So is there any bigger project coming up in Tamil Nadu so that there should be a comprehensive solution to this problem?
Exactly, sir. This was the first interlinking project in Tamil Nadu. Subsequently, we initiated another project called Kaveri River bypass. So whenever the flood occurs in Kaveri, so the flood water is being diverted and linked with Kundar and bypass, which are all road-prone areas of Tamil Nadu. So like this south part of Tirunelveli and Kanyakumari. So those part, middle part of Tamil Nadu is also prone to severe droughts. And actually, the groundwater has been depleted due to various reasons, due to over exploitation, poor rainfall, erratic rainfall, and hydraulic cycling, and even climate change also. The vagaries of monsoon, everything is there, sir. So two projects, interlinking projects, right now in Tamil Nadu, and through pumping also we are in execution two projects. One Atikada ONS project, so afternoon we will discuss about that, and the Salmanga pumping. So we are lifting. So earlier in Tamil Nadu, we don't have any lifting projects for irrigation. So only water board, Tamil Nadu Water Supply and Drainage Board having pumping project for only drinking water purpose. So right now, 2018, we just made our thought in a different way, and we are introducing that irrigation for both drinking and irrigation projects. So two projects are right now on today. So probably afternoon, I will take the subject, Atikada ONS pumping project. Thank you, sir.
Okay, thank you very much.